there's a form that tells you what kind of differential equation it is, and then there's the form that's easiest to work with in order to come up with a solution to that differential equation. So what I'm going to do here is take my model, some function a of x times the derivative of y plus some function b of x times y equals c of x. This a of x, b of x, c of x, they're known as coefficient functions. All right, so there's some function or functions that act the same way a coefficient would, or a constant multiple. All right, but they're functions rather than actually being constants. All right, so what I'm going to do is divide out the ax. A of ax. Technically there's an a and there's an x, but that's not how it's said. All right, so it would cancel for the first term, and you would be just left with a y prime. Then you would have plus b of x over b of x over a of x times y equals c of x over a of x. All right. And because very often, not always, but very often, the coefficient functions end up becoming ratios when you get it into this form. Sometimes they simplify down nicely, but it's going to be the result of dividing two functions. What we do is we come up with a dummy function to represent each of those ratios. So we use p of x to represent the ratio of b of x to a to x. And then we use q of x for the other one. Actually, as it turns out, all you really need is the p of x in order to solve a first degree or linear differential equation. All right, so these problems below, they really just focus on getting it into the appropriate form. Sometimes it's a minor adjustment, sometimes it's a significant adjustment. So in the case of the first example, I want it to look like this. This is my standard form. All right, I want it to be y prime plus something y equals something. Doesn't matter what the somethings are as long as the y prime and the y are in the appropriate locations. So that's telling me I just need to add a 4y to both sides. In this case. And so we would have y prime plus 4y equals 3x. From this, all this question is asking me to do is identify what the p of x function would be and what the q of x function would be. So that's my p of x. And that's my q of x, lowercase. All right, this is a skill in and of itself. For question number one, it's not an overly challenging skill, but there's some of the other ones that will be, because you look at number two, you see it's a little bit messier. I would want to cross multiply first, perhaps. So 3xy prime equals 8y minus 6. And I want my y's to be on the same side. Any variation of y, whether it's a prime or otherwise. Subtract. I'm looking at 3xy prime minus 8y equals negative 6. Now, the condition, one of the conditions to be in the standard form is to have no coefficient or a coefficient of 1 only for the y prime. So that's telling me to divide everything by 3x. So this would become y prime minus 8 over 3x times y equals, well, that would be negative 2 over x. And again, whatever your coefficient is of y, that's your p of x. Whatever the coefficient or the lone constant function would be, well, it's not really a constant function. It just acts like a constant would in a linear equation. All right, that would be your q of x. Whatever's all by itself on the right-hand side. All right, and we're going to have to do something with these, something calculus-y with these p of x's in a couple of seconds, so pretty important. And also take note of what, if any, domain considerations you might have. So in this standard form, I would know x can't be equal to 0, because then each of these would be undefined. But in my setup here, they said x has to be more than 0, so I knew I didn't have to worry about that to begin with. All right. Now, the last one here, also not too bad. I subtract a 3y from both sides. 3y prime plus y equals negative 4x squared plus 5. Then I divide everything by negative 3 to get the y prime alone. I'll do it this way. So I'd be looking at y prime minus 1/3 y equals 4/3 x squared minus 5/3. So again, whatever the coefficient is of y, that's your p of x. The lone expression on the right-hand side is your q of x. Derivative.